Select the major product of the following series of reactions. So we want to look at what we're starting with, and we want to look at our reaction conditions, and we're going to go through this stepwise. So we see that we are starting with this primary alkyl halide. And in the first step, we're treating this with sodium cyanide and DMSO. So let's remember what we have here. So whenever you see a sodium in front of something, it's the counter ion, and sodium always has a +1 charge. So that means that this Cn next to it, and this is the actual structure, this is the cyanide ion, and it must have a -1 charge to balance out that +1 of the sodium. And then DMSO, you may remember from the first semester of organic chemistry. So this stands for dimethyl sulfoxide. And what this is it's a polar aprotic solvent. So it is the solvent. It's not going to appear in our product, but these are really good conditions. We got a good nucleophile, a polar aprotic solvent, a primary alkyl halide. This first step is an SN2 substitution. So what's going to happen is that cyanide ion is going to attack the carbon that the bromine is attached to and displace it. So it's forming a bond with that carbon atom. So what we are forming then is we are adding a cyanide exactly where that bromine was. So C triple bond to a nitrogen. So when we're doing this, we're substituting that bromine, but notice we're also adding a carbon to the carbon chain. It has gotten 1 carbon atom longer because we started with a chain that had 1, 2, 3, 4, 5 carbon atoms. And now we have a chain, so 1, 2, 3, 4, 5, with 6 carbon atoms. Okay, and we have also changed the functional group, so we now have a nitrile. So we have a nitrile. And so this is the product of the first step. And then in our second step, you're treating this with H3O+ and heat. These are hydrolysis conditions. And you may remember from previous videos that any carboxylic acid derivative, and a nitrile is a carboxylic acid derivative, can be hydrolyzed to give you the carboxylic acid. So this is your acidic hydrolysis conditions. And so that's the second step, is the acidic hydrolysis of a nitrile to make a carboxylic acid. And so in the carboxylic acid product, that carbon that I've labeled number 6, and this is just numbering to count the carbons. This is not numbering for our IUPAC naming, just keeping track of our carbons. This carbon here where you have the triple bond to nitrogen, that is going to be the carboxylic acid carbon. So you're going to have 1, 2, 3, 4, 5, 6, and this 6th carbon is going to be a carboxylic acid. So we can number these again so we can see how to keep track. Okay, and then we want to look at our options, and this looks like option A, but let's number the changes to make sure we are counting correctly. 5, 6, and the difference between this and C is the number of carbon atoms. So C is not going to be the right answer because we need to recognize that when we add that cyanide group, we are actually also adding a carbon and elongating the carbon chain. So this option A here is the correct answer.